Hello, welcome to part 4. Last time we added the infrastructure and a button for actually hooking up the solver to our game. So you can see there was some test data. So now we can actually go about implementing the logic. So the first method we're going to use for solving the board is when we have a cell where the number of mines remaining around that cell is 0, then we know all the empty cells around that cell cannot contain a mine. So in this example, we've got no mines left to place down, so we know all 3 of these cells can't contain mines. And likewise here, there can't be any mines in any of these cells. So we're going to do we'll write a test first, I think, for this. There's a few different ways we can test this. I think the easiest way for them to get started is we give it the whole board, we click solve on it, and then we'll make sure it's correctly solved that square. So we'll create a new test, and we're just going to call this first method just method 1, I think. So we need to first of all populate the game board with our given state. And our game takes its state in as a array. Did we do this already? Yes. No, I forgot to create the method. Solve first cell. And we should have put the fact attribute on the method, not on the class. Right, that's a bit better. Then result dot. Oh yeah, needs to be public. This is our solution. So solution. And then we can do some assertions on this. So we can assert so we can do the description, say no mines left in place. The cell of interest. So it's actually 0, 0 in this case. And then there should be 3 solved cells. So the first one we're going to solve is the first column and the second row. Then we'll have the first row, the second column, and finally second column, second row. So the only thing left to set up is our initial game state. Okay, so that's our first row. Get there in a second, and that's our second row. Okay, so it's going to be 8 columns, 2 rows. First column, first row is 0. So then so position 4, so 1 and 6 and 7, and then our second row is just there, which is 5, 1. That's going to be mesh 3, and the rest of the board can be empty. It should be fine for this test. The other thing we need to check is after we solved it that we've actually updated those columns, so we know. So we're expecting to contain an empty, which is an X. So that's going to be 0, 1, 1, 0, and finally 1, 1. So what we're saying here is we're starting off with our initial state with just that. After we solved for that square, we can have repopulated those 3 with our mines. With the fact we know there isn't a mine there. So if we run this test now, we'd expect this test to fail because we haven't written the implementation yet. We just need to make sure it's failed in a way we've expected. Okay, let's take those lines out. Okay, yes, so it's already failing. Okay, so what we're going to do is we're going to examine each cell in turn and check to see so we'll examine each cell in turn. We'll look at how many mines there were there originally. We'll subtract how many mines we've already found in our neighbours. Calculate how many neighbours we don't have. We'll start with how many mines we had originally, and we'll subtract how many we found. If the result is 0, we know that any empty spaces can't contain a mine. So I think that's probably going to be easier than it sounds. So we do column first, and then row within that. So first of all, we need to check that we're only interested in cells that contain mine counts. So if cell contains mine count, so then we need to get all the neighbours which have mines. Neighbours count all the ones which are unknown, which are unknown. So now we can work out how many mines we've got left to place. So actually, maybe we can say try does so mines left to place is going to equal our original count less number of neighbours we've got with mines, and then if we've got that down to 0, we know that any empty cells must contain, or cannot contain any mines. So, the cell we just examined was column and row, and maybe this could contain, if this returned an array of cell locations, then we don't need to do anything else at all. And then finally we need to make sure we populate all these or mark all these as being empty. Otherwise, if we drop down to here, we haven't managed to solve it, so we just return null. Okay, we just need to make this compile now. If the cell contains a value that is greater than or equal to 0, well, that's probably what we need to say actually. If it contains a value that's greater than or equal to 0, then the mine count is that value. And we can return true. Otherwise, we don't have a mine count in that column, so we can set that to be whatever we want. Meaningless, and we return false. Okay, then we need to find our neighbours with mines. So that's going to return that needs to return an array of cell location. We've got all the neighbours for this cell. And then we filter them and we can do the same thing for neighbours which are unknown, neighbours with mines. Okay, so now we need to actually work out what the neighbours are of a cell. Okay, so I don't think there's a particularly easy way of doing this. I think maybe that might be like this rather than the right. So we'll start off with an empty list. Which we're going to add our neighbours to as we find them, and we'll return that at the end. So we just need to work out what neighbours got. So we've got up to 8 possible positions. If you think about it, we've got move to the left, we have 1 above, that's the cell we're looking at. We can have 1 below, or we've got them to the right. Maybe if we number these, and we can do them in this order. Okay, so So 0, 0 is the top left. So I'm going to say if column is greater than 0 and row is greater than 0, then we can add the second one. We just changing the row, so we don't need to change the column. Third one, we're adding the column, so we need to make sure the column is less than -1. Yep. So for 4, we're just changing the column, not the row. For 5, we're increasing the column again. So if we're in column 3, okay, we're in column 2, and we increase it. So we only increase it if we're less than, yeah, that's right, I think. And then finally the bottom row. So in this case we add the row number, but we need to do a similar check for the row, so the row has to be less than number of rows equal 1. Okay, so the theory is we look at each cell in turn by looking for all the columns and rows. We check that the cell contains a mine count. If it does, this function returns the mine count into our variable there. We then find the number of neighbours which we've already found mines for. We then find the number of neighbours which are still unknown. The number of mines we've got left to place, therefore, are our original mine count plus the number of neighbours we found with mines. If that value is 0, then we know that all our neighbours must be empty. So we can go through, so all our neighbours are empty, and the solution we can return is the cell of interest was the one we'd got to in our examination. The cells we solved were all the ones that were unknown, and we've got a description. Let's see. The problem is our test was quite complicated, so if this fails, we'll have to work out whether it's the test or our code. Oh, it has worked. Okay, let's try running it, see what happens. Okay, so that's done correctly. So now it's going to continue walking the board, so I think it's going to solve that. Nope. Okay, so it's not getting past there the second time because this one's still got 0 to place. So we also need to check we've actually got some neighbours. Otherwise, it's just going to keep applying the logic to the same one. Okay, I wonder why it solved that one first. Ah, because we're going, yeah, columns first. Okay, so we got to that one. Then we got to this one. Okay, and that's as far as we've gone, so the results will be null. Okay, that makes sense. So the technique we're going to look at in the next video is where we've got cases like this one where originally we knew there should be one mine. We haven't found any mines yet, and we've only got one remaining square. Therefore, that must contain a mine. Thank you for watching once again.